I'm going to solve this equation twice. I'll solve it once like we already learned how to solve, and then I'll solve it once using a slightly different strategy that involves the change of base. Right? First, if I was going to solve it like we already learned, it's already isolated, so I don't have to do that part. What would be the next step? Take a log of both sides, right? So log of 2 to the 3x equals log of 172. Then what would I have done? I take the 3x and I move it to the front. Oops, that's wrong. Then divide by log 2. Which gives us 3x equals that. And then the last step, divide by 3. So x equals log of 172 over 3 times the log of 2. Okay. Here's the other way to solve this. Normally at this step, we don't take log base 10 of both sides. Normally, we use another property of logarithms, which was not presented in the book, which goes like this. If you take the logarithm of a base of an exponential, which has the same base, taking the logarithm of an exponential where their bases are the same, they cancel each other out. That is like doing the f of f minus 1. When you match these bases, they cancel each other out, and all you get is what was in the parentheses. So when I take logarithm base b of b to the x, this exponent is the answer. These cancel each other out. So I would take not any base there. I'll take log base 2. Take log base 2 of both sides. Log base 2 of 2 to the 3x equals log base 2 of 172. Now, how does the left-hand side simplify based on what I was just saying up here? You just get the 3x, right? Because the logarithm, the base of the logarithm, matches the base of the exponential. That's like taking f of f minus 1. They cancel each other out, and now all you've got is 3x. 3x equals log base 2 of 172. But again, if we didn't have a log base function on the calculator, at this point, we would have to do a change of base. And this is the example I gave you on the last slide. The change of base would have been log of 172 divided by the log of 2, right? It's 172 over 2. And then last step, divide by x. Well, if you notice, it's essentially the same math, right? We ended up doing all the same things when we took log base 10 as when we took log base 2 in order to use that property. In the end, it's pretty much the same thing. And because they didn't really present this as a property, in this section to solve equations, I think we're probably better off just to take log base, in almost every case, just use log base 10. There'll be one exception where I'll recommend let's not use log base 10. Does anybody have a guess what that might be? Which other log might we like to keep in the base that it is? Nope.